Hello, everybody. I think it's slowly time to start. It's already 6:05, so we are 5 minutes late already. Sorry for this. Welcome to Munich .NET Meetup, to another meetup. Today we have Kai with us to make an introduction for F-Sharp, about F-Sharp. It's very interesting. Hello, a nice background. I should do that. I always remember to do that when I see someone else with a background. So just before we start this very interesting session, I was waiting for this because we're already hearing about F-Sharp, a lot of things around how C-Sharp is actually stealing functionality from F-Sharp. F-Sharp is like the playground of C-Sharp, it seems so. So just before we start, a few notes. First of all, we are recording right now this session, so if anyone objects to this, send me a message and we will blur you out, blur your whatever you say, we'll blur your screen, whatever you want. So we'll not have any problems there, no worries. Yeah, this is just to be sure that we are in the right meetup. You see, I have it as a screen here, but I don't have it as a background. Anyway, if anyone wants to ask something, it can send it in the text message. I will monitor the text message all the time. Or there is, I think, some sort of raise your hand thingy, I think somehow. Anyway, no worries. We are not so many people, so you can just open your mic and ask something. I think we will have some time in the end of the meetup for questions. Yeah, I think Kai, the stage is yours. You can start whenever you want. I will close my camera because I had some internet connection problems today, so I don't want to stretch it a lot more. Yeah, Kai, the stage is yours.
All right, yes, thank you. I will ask you to stop sharing your screen so I can share my screen.
Sure, yeah. We just tested that and I forgot. I am stopping now.
And with that, I hope everybody can see the starting page here. So my name is Kai Ito. I have been developing professionally since 2012. It was back then. It was all C#, ASP.NET. Also full stack. So on the front end, just simple JavaScript jQuery. And then F# I learned in 2016, so 4 years ago. And since then, it's become a passion of mine. Functional programming in general. I find it really the greatest because of the amount of safety that it offers. Compile time safety, type safety. It's a good combination of concise code, but at the same time being very, very expressive. And I've been trying to get everybody else to learn F# since I learned it. So yeah, you can find me on hashset.dev. That's my own personal blog site. And there's also a link to my GitHub and a link to this talk itself on the slides, these slides here as well. So with that, what is functional programming? So I don't know how we can easily see this, but does anyone have experience with F#? I don't know how we can see the chat.
Well, I do have some, and if anyone else has some, I think that you can add the reactions or something like this one, right?
Ah, yes, I can see your thumbs up. Yes.
Yeah. So I have a bit of experience, but I mean, not professional. Of course, it was more or less like a playground. Let's say I had some experience with Q# and F#. Since the lockdown, we owed to ourselves to make it the time we spent inside a bit valuable. So this is my only experience. It would be a nice opportunity for me to start now, though.
All right. Yeah. Okay. I see some other thumbs up as well. All right, so the basics of functional programming, it focuses on data flow. It always also has that concept of function composition instead of inheritance. And it also prefers to use expressions instead of statements. So in this particular talk, I'm not really going to go into the specifics of how functional programming is different from imperative programming or object-oriented programming, but there is a fantastic talk by Li Haoyi, which is what is functional programming all about. And there will be a link to his talk at the end. But I will mention just a couple of quick points about functional programming. The functional paradigm. There's a lot of usage of higher order functions. So essentially a function which returns a function, or a function which takes other functions as some of its parameters. These allow you to represent various higher level abstractions. You can, there's a lot of code reusability that's possible with these things. A lot of the functions are also known as pure functions. Essentially a function that every time you run it for the same inputs, you always get the same outputs, meaning no side effects. You're not writing to a database. You're not printing something to the screen. And these are very useful because they're easy to reason about. They're idempotent. They're very easy to test. Along with that, functional programming likes to make use of immutability. So practically everything's immutable. You just can't change it. So once you've declared a value, that's the value. You're not changing it. And if you want a new value, then you got to declare a new value. You got to return a new value. And that's useful because it's very predictable. It's automatically thread safe. And I'm just going to say this, there's less bugs because of it. Just a blanket statement. You'll have to trust me on that. At this point in time, you'll see why that is as I go along this talk. There's also a couple of quotes that a lot of people like to say when it comes to functional programming, especially people over on the Haskell side of things. And if it compiles, it works. And then there's also this concept of a pit of success. And what this pit of success is, I will tell you now. So classically, a lot of the times you hear about the mountain of success. This concept can be applied to any project that you're working on. It doesn't have to be programming. It can be anything else that you learn. And the idea is that the path to a successful project, to a successful piece of software or hardware or whatever it is you're creating, it's a lot of hard work, and it's a constant uphill battle. You have to learn this, you have to learn that, you have to make sure that all these concepts fit together. And then once you're finally at the top of the mountain, you've done it. You've successfully created your product. However, as you're trying to keep your product there, if you just accidentally push it off to the side because you make a small mistake, there's a short deadline that you have to implement a hack, then suddenly the ball rolls down the hill, and you have to start all the way up again with difficult refactors, with fighting deadlines, and all of that while you now have some hacky code. The opposite of that is what's known as the pit of success. This, as you can see from the diagram, is the exact opposite. It's once you have a language that enforces all these functional ideas, then falling into where you want your software to be, where you want your code base to be, is really easy because the compiler forces you. The compiler forces you to do things in what's already the correct way. And if you're trying to implement hacks or workarounds, that's actually more difficult than doing things the correct way. With things like immutability, if you're trying to mutate a value, you have to go out of your way. You have to use additional keywords. You have to use additional syntax. So that becomes very, very obvious, for example, in a pull request that you're mutating something, and then your team members can ask you, hey, why are you using mutation here? And then it can start the discussion of how you could maybe do it in a different way. So this is a concept that I've definitely found to be true when anytime I've been using F# over other languages, is that the compiler helps me do things correctly. So that's the basics of functional programming. What is F#? It's a functional first language, but it's still multi-paradigm. So you can write, you still have classes and objects. It runs on .NET, so, and of course Mono, Xamarin, .NET Core, everywhere where C# runs, everywhere where Visual Basic runs. It's first released in 2005 by Microsoft Research. It now belongs to the F# Software Foundation, so it's community run. And it's completely open source. The compiler, the tools, the standard library, the .NET runtime as well is open source now. And it's a lot of fun. The syntax, in a nutshell, it's based off of ML. So for those of you that are familiar with standard ML from a long time ago, that's what it's based on, which means it's a statically typed language and it prefers type inference. It's whitespace significant. So for those of you that like Python, you'll like this as well. It's expression based. So everything is an expression. There's no statements. And everything's also immutable by default. So as you can see here, we're declaring an integer. So let would be the keyword for it. This is an int, it's just the name we're giving it, and then 1. So it automatically knows that this is an integer. Same here with a string. But you can always just add a type annotation if you want, just to make things more clear. So in this case, it's a Boolean. And here it's also, here we have a list of floats. And this is, once again, it's all inferred. So the compiler already knows what type this is. And same thing with an array of strings. So it's slightly different syntax to the list. But here you can also see we have no semicolons and it's actually whitespace significant. So if we didn't have these spaces over here, then it wouldn't compile. Functions, they're first-class functions. They can be passed around just like any other values. And then the last expression in a function is what's essentially the return statement in any other language. So very simply, we define a function called add. It takes in 2 parameters, a and b. And it has automatically inferred those to be ints in this case, although they could technically be strings as well. That's, I think, just a simple oversight in this markdown parser here. The int should actually be a generic type. But we are returning a plus b. Or in this case, we're defining a function called sign. It takes a num, which is an integer. In this case, it is an integer, which it's figured out because we're doing comparison on it against another integer. So here we have an if, else statement, which returns a string. So this entire function takes in a number, which is an integer, and returns a string. And lastly, we have an example of a recursive function. And what's here is a pattern match. So for those of you that have been following the C#9 specifications, this is what you'll be getting. And I think C#8 even, yeah, I'm sorry, C#8 introduced the C# version of pattern matching with its expression switch statements. This is where they came from. So essentially we're checking n. If it's 1, we're returning 1. If it's 2, we're returning 1 because that's what we're doing Fibonacci. If it's anything else, we're binding that integer to n again and returning the recursive call to Fibonacci n minus 1 plus Fibonacci n minus 2. We do need to mark this as a recursive function for 2 reasons. One is to simply help the compiler, hey, this is a recursive function, so you can do things like it can optimize for tail calls, for example. But at the same time, it's also, F# is a single pass compiler, so it essentially parses the text top to bottom once. So it just needs to know ahead of time that the function is going to be recursive. Piping, this is an interesting concept that you'll find in a lot of the functional first programming languages. So F# obviously has it. Elixir would be another example. Haskell also has it. And for those of you in the JavaScript world that are following the proposals, they're also thinking about implementing this. But essentially, what's happening here is we have this pipe operator, and all that means is we take the value from before the pipe operator and we apply it as the last parameter in the function. So this list.filter function, it takes a predicate, just like in C#'s list.where. But we also need the actual list that we're operating on. So in this case, we're creating a list from 0 to 100. And that's going to be our parameter for list.filter. That entire, what's the return value out of this list.filter, we're then piping to the list.map. So now that we have all even numbers, we're going to map over them, and we're going to raise them all to the power of 2. And then we're going to take the return value of that and pass it into, and iterate over that and pass it into this printer function, which we've defined up here. And all that does is print to the screen. So this last statement is the exact same as line 7. So this is just an example of being able to pass a function as a value instead of having to declare a anonymous function. And the definition of the pipe operator is very simply just take the value in a function and apply the value to the function. And you can define your own operators in F# with by first surrounding whatever special characters you want in parentheses. Okay, moving on, records. So these are what I was thinking of in C#9. Once again, they come from here. They're simple aggregates of data, to put it simply. They can be a struct or reference types. By default in F#, they're actually reference types. In C#9, they're, I think, going to be struct types. But in F# you could just add an attribute to also make them structs. What's much more interesting about them is that they have structural equality instead of referential equality. So I can, here's the definition of a user object. So first name is a string, last name is a string, age is an integer. And then I can define a value of Kai. And here you can already see it's of type user. What's interesting to see here is that nowhere in this definition have I actually said that it is user. This is once again where the type inference comes into play, and it sees that the only fields inside of these brackets are the first name, last name, and age fields, which appear in this definition. And I can declare a clone of me essentially with the exact same values. And then if I do a comparison, which in F# is only a single equal sign, you can see that the output is true. And these are still immutable, but if I wanted to update a single value, I don't have to write out the entire thing. There is what's called a copy syntax, where it will reference the original record that I want to copy, and then I simply update the one field. And then if we're taking a look at older Kai, then the ages have been updated, but the original Kai, the age is still 88, because that's not how old I am. Yeah. Discriminated unions. I'm not sure if C#9 is getting these. I may have read that they are, but I'm not sure. But these are very powerful construct, which I'm a big fan of. And the basics of it is that it's an enum where each enum value can optionally have its own value. I don't know how else to really say that, but to put it simply, we declare a shape type, and it can be either a rectangle or a circle or a triangle. If it's a rectangle, it must also have a tuple of 2 floats. If it's a circle, it must have 1 float associated with it. Or if it's a triangle, it must have a 3 tuple of 3 floats. And if I want to declare one of these things, a rectangle, I would declare it with the rectangle constructor, passing in a tuple. Same thing with a circle, same thing with a triangle. But also note here that these are all of type shape. So then if I have a function which takes in a shape, I have to use a pattern match again to figure out what kind of shape it is. So essentially it passes in the shape, it sees if it's a rectangle, it then automatically deconstructs the tuple into my width and length, and then I can do whatever I want with the values. Same thing with a circle, it will automatically deconstruct the float into radius, or the triangle, it can be 3 floats. These don't have to be all floats, some of these can be integers or doubles or strings or any data type you want. So what are the benefits of the F# type system? There just is no null. That's 90% true. The 10% is where null exists in the .NET framework because it does need to interface with C# and other .NET languages. But if you just try to declare a value with null, it won't let you, compile error. So using a combination of this no null attribute as well as a combination of records and discriminated unions, it's possible to make illegal states unrepresentable. And with that, you can use types to represent the domain. You can also use types to encode business logic even. And then this last point is a very interesting one. Files and code must be in dependency order. So essentially, any code that you declare at the top of a file cannot reference code that you declare at the bottom of a file. And same thing with files themselves within a project. A project file will need to specify the order of your files. It's not automatically alphabetical. It's defined in the order that you need them, and files that you declare at the top of your project cannot reference functions or values in files lower. This may seem like a bug or hindrance or something bad. And I admit, when I was first learning F#, it definitely felt like a big pain point. But it's turned out to be one of my favorite features, and it really forces you to think about your data flow, and it really makes it difficult to accidentally call a function that you're not supposed to call from elsewhere. For example, you want your controller function to call the database and then construct a domain object out of that value, instead of accidentally calling the database from the domain object. And just having this check here in place really makes that easy. So how do you deal with null values? So there's something called the option type, and it's large parts of the standard library use it instead of returning null. And at its core, it's a discriminated union with a generic type, and it's either a sum of that generic type or just none. So we can declare a valid string of some text or an invalid string of none. And once again, you can see that the types in each case is string option. And to show that where it's used in the standard library, for example, we have a list of words. And we can use the list.tryfind method where we're looking for a word within this list, and it will find it. And here you can again see that it's of type string option. And again, if we're looking for another word that doesn't exist, it's still a string option. However, now that we've found our word, how do we actually print this word? Because if we just try to straight up print this string value, we get a compiler error expecting string but gets string option. So this is once again a part where the type system and the compiler forces us to do things the correct way, which in this case is we have to pattern match on our input. And if it's some, we deconstruct the string into S, and then we can directly print the S. And if it's none, then we just don't find the word, we do something else. And the compiler has what's called exhaustive pattern matching. So it will warn you if you're not handling every case. So it knows that this is an option type, which means it knows that there's 2 possible values. And then the compiler will tell you, hey, you're not handling every case. So there's a compiler check, making sure you do things correctly again. And using this option type, we can make illegal state unrepresentable. So we can imagine a scenario where we have a contact user, and the business logic says that they must have either a phone number or an email address, or they can have both. Now, if we were to do this in an imperative approach in a language that didn't have this powerful type system, we would probably have some kind of logic here where we checked email address and phone number, and then we would have some additional logic that checked that at least one of them was set. And then we need to write unit tests, and it's easy to make a mistake. And then suddenly we have a null reference exception. So how we could do this using the option type and discriminated unions. We could define a contact information discriminated union, which is either an email or a phone number or an email and phone. And we can define a record of a contact with this contact information. Now we can create our users where the contact is email or the phone number or the email and phone as defined here. However, if we were to try to create a safe contact user where the contact is null, we'd get a compiler error. Or if we were to try to create a contact where it's just directly an email address or just some other string, we would still get a compiler error because we're not sure if that's an email or a phone number. So this is once again one of those places where the compiler and the type system really tell you, hey, you're making a mistake here. You got to do things properly. And once again, touching up on this point is within the FS project files, this order of files, the order of these files is defined, and code here cannot reference code here or anywhere below. Code at the bottom can always reference code before it. And as I mentioned before, this is really useful for when you have certain separation of concerns, for example, your database layer, your domain layer, your controllers, and you can create what's called the onion architecture, where you have outer layers can reference code inside, but the inner layers cannot reference code outside. And I forgot to actually include a diagram of that here, but it's a well-described architecture pattern. And if you're trying out F#, this will be painful in the beginning. But I assure you, it's one of the greatest things. It's one of the great parts of F#. And so these are some of the things that really help you into this pit of success, where the compiler really makes sure that you're doing things correctly. So before I move on to just general more functional concepts, such as function composition, do we have any questions at this point?
Yeah, I do have one. I wrote it in the chat. I haven't figured out how to raise my hand though.
That's fine. Go ahead.
That's okay.
The question is, now you have this linear order of references that are allowed. If you were to implement an onion architecture with this, the onion architecture, the allowed references aren't hierarchical. And yet F# forces this hierarchical reference order on you. So how would you prohibit the outer layers, for example, different adapters from calling each other, which they're not allowed to do?
Yeah, so it's not perfect. So if within a single project you have this hierarchy order, however, if you do have multiple projects, then they can call each other.
Okay, so the references between the projects are explicitly set up, so you can do whatever you want. Okay.
Yes. Yeah.
Yeah.
And the last time I held this code, there was also the talk about circular references. There are also ways around that. With a special keyword, you can define a type, and then using the keyword "and," you can define another type, so you can have circular references. And there's a couple more syntax tricks like that. But it's always that the default case is the stricter version. Okay, so I'm going to move on then into just other general functional paradigm concepts. So I'm going to talk more about function composition. So this is essentially the idea that you can combine two functions together to make a new function. It's a very simple concept, but if used properly, it can become very powerful and introduce a lot of code reusability. So the basic idea is if you have a function that turns a circle into a star, and another function turns a star into a triangle, we can compose those together to make a new function which turns a circle into a triangle. Very complicated stuff. What this looks like in F#. So we define a function, in this case, a very simple functions, where we take a string and we parse it into a date-time object. And then we have another function where we can get the year component out of that date-time. And then we can compose these two functions. So here I've defined a composed getYear value, and it has a signature of a function which takes a string and returns an integer. And we're taking our parse datetime function and we're composing it using this operator with a getYear function. And something else you'll note is that we're not defining the parameters here. We're just directly using the functions. And then we can use the year from composed, where we give it a string and we get an integer out of it.
And this would work entirely without type annotations as well.
Yes, exactly. So these are optional here. Optional. There are some cases where they're not optional, where the type inference gets confused, but it will be very obvious that there will be a compiler that says ambiguous usage of types. You may need to specify type annotations. But in this simple scenario right here, it's all optional. Now, I could go into other more useful examples, but before I do that, I do want to talk about function currying and partial function application. And this is the idea of creating new functions by not supplying all parameters. F# curries all functions by default, and essentially also, what does it actually mean when a function signature has int, arrow, int, arrow, int? So if we look at our add function again, it takes in 2 parameters and returns x plus y. But what the compiler actually does with it, it creates a function with 1 parameter, x, and it returns a function with 1 parameter, y, which does x plus y. And this works for any number of parameters. So if we have 3 parameters, first name, middle name, last name, the compiler automatically turns it into a function that returns a function which returns a function. So this is currying. And then we can partially apply these functions by only supplying a subset of parameters. So we can create a curried add function by only supplying 3. And then we can use this curried add function by supplying the other parameter. So 3 plus 5 would be 8. Or for example, we can even use an operator like a function, because that's all they are, by partially applying 2 to one of the operands of the multiplication. So now if we create a list from 1 to 10, and we map through the double function, we get 2, 4, 6, 8, 10. And then what's interesting is it's a concept called point tree programming. It's what happens when you just abuse currying and partial function application, and then you just throw away the parameters everywhere, and then just use higher order functions. So a simple example, which would be sum. We're creating a sum, which takes in a list. And then we're just going to add all those numbers together on this list. Or we can define that with a point tree style by just leaving the parameter out and then leaving the parameter out over here as well. Both of these functions do the exact same thing. Or a more useful example would be batches of n. So if you have a list and you want it to batch it, then you can, in this case, we can map it with an index and then compose it with a group by, where we take the first of the tuples and compose it with the second of the tuples and. So it's, this part here is a little bit complicated to read, definitely. But if you're just reading the name of the functions, then you know exactly what it does. And this here should be 10, not 4. So my apologies, small mistake. So how to use this batches of function? If we want a list and batches of 2, and then we get a list of lists out of it. However, you can also just do some really weird things with it. For example, we have a double increment of x, so x times 2, and then plus 1. Or if we do it in a point-free style, we can partially apply 2 to the multiplication operator and compose that with a partially applied 1 to the addition operator, which is just silly, but it's possible. Like it's so ridiculous that the syntax highlighter got confused here as well. But yeah, that's just something fun you can do. So now I want to switch over to a code demo. I hope everybody can see this. So if we have a simple web server that has a get function and it takes in two functions as parameters, get a user from database and a formatter. Interestingly enough, this is also how you can actually do dependency injection in F#. No need for interfaces or classes and implementations. You can just have functions as parameters. So imagine we would get a request from the web, get the user by ID 1, and then we would fetch it. And then we would take this user object from the database and pass it to the formatter function. Our formatter function is essentially just a JSON serializer. And if we're in a production environment, we want to minify the output. And if we're in any other environment, then we don't. And then just this would essentially be a database call, but in this case, it's just returning a record. And then if we run this, for example, we can see that our environment is production. So we have partially applied our JSON serializer function. It takes 2 parameters, but we're only supplying 1. So we have a formatter function. So you can see here the JSON serializer as a function takes a Boolean and a generic type of anything and returns a string. And now here, now that we've partially applied the JSON serializer, it no longer takes a Boolean. And it knows that it takes a user object because of how we're using the formatter function elsewhere, and it returns a string. So because of our environment is production, our JSON response is minified. However, if we switch our environment to anything else, then our JSON now has white space included. So that's a quick, useful example of how you can use partial application and function querying. Any questions at this point?
Seems we are okay. I don't know if it is because we don't have any questions or because we don't understand the thing. But yeah, it seems to me that it's a bit more important to have correct variables names, functions names, even commenting your code a bit better, because at least for my inexperienced eyes, sometimes it's quite difficult to understand what a function is doing. Even the formatter, for example, I had to read carefully every line. So that's probably because of my inexperience, though. But I guess it would be a bit useful to have proper names, right?
Yeah. So it's that's also something that I struggled with in the beginning. It's the syntax is very different from the C style syntax. It's very different. So it does take a lot of getting used to. And then a bigger problem is that because it runs on .NET, you can use any C# method. So right here, the JSON serializer is actually coming from the standard library, which means it's expecting our parameters to be passed in with the brackets and a comma, which F# doesn't really, thinks it's something different.
So you're mixing syntax there.
Exactly. If I wanted to write this in the F# style, I would have to do F# serializer data options equals, and then I would have to move this up here because of the dependency order. Serializer options, I then need to define, so right here, the type inference is actually getting confused. But it does know a couple of suggestions. So we need to help it. And now we can use our version.
Okay.
Whoops.
You called it JSON serializer option.
Yes, exactly. Thank you. So yeah, so this way we could then now use our F# syntax, and now we could also partially apply it if we wanted for whatever reason. We wouldn't be able to partially apply the standard library version without having a wrapper like this.
So you can always annotate with the types and give the arguments names instead
Exactly.
of actually commenting.
Exactly. So these comments here are actually they're not comments that I wrote. They're actually from VS Code. This is a comment from me, but this is from the CodeLens extension. So VS Code has a absolutely fantastic extension called Ionide. And it actually adds those comments into CodeLens to tell you what types it is being inferred. Visual Studio itself, the big Visual Studio, can also do this. Yeah. But you know, if I say it's up to your team, make a team decision how you want to write it. Do you always want to annotate your parameters, or do you only want to do it when you're necessary? It's a team decision. Okay.
What would you suggest based on your experience? I mean, what we learned in a more maintainable and readable code?
A combination. A combination of the two. So in this case, having a web server where where it takes these two functions, here it's very useful to have these type definitions because we have no idea what this users from DB functions would take otherwise. We wouldn't even know if this is a function at all. In this particular case, the type inference does know about it. But for example, if you're reading it on GitHub or during a pull request, you wouldn't be able to see this IDE help. Other times, if I call this a JSON formatter, then I think I would know that it's a string's going to come out of it. So it's really. I personally like a combination. Yeah.
Okay.
Maybe when you're first starting out, it's nice to always include it. Something that you do need to watch out for is this JSON serializer options is actually the type of the serializer options here. But right now, F# compiler thinks that the return type of this entire function is JSON serializer options. So I would actually need to make sure to do that with brackets and then declare the string like that.
Also, annotating everything is a double-edged sword, I guess, because
exactly.
It keeps you from refactoring. Like if we would change this user from DB function to not take an int, but say an ID of int,
yep.
Then you would have to change all your annotations. Whereas with type inference, F# would figure it out on its own and still mark the code that it doesn't know what to do with.
Exactly. And then if you remember our very simple add function, why does it say int? It doesn't matter. We can that should work, I think. What are you complaining about?
Typo.
Yes. So now it thinks it's string, string, string. Then if we also have an integer version, no, it doesn't work right now. Okay. So we can really declare this with generics as well. Sometimes that'll work automatically. I'm not 100% sure what I'm doing wrong right now.
And the generic F# should figure out the type constraint on the generic, namely that it needs to have a plus operator defined on it.
I'm doing something wrong right now, but usually this would work in other cases. It would need
Probably
to
just syntax.
exactly. It usually would figure out that it's a generic type, and you could use it in multiple places without specifically having to specify that it's generic. The problem is you might run into performance problems because it would have to box everything first. And if you don't have type annotations, you might forget about it. But that's a future you problem.
So it does need to box despite them being generic types.
In this particular
contrast to C#, where generic types were introduced to avoid boxing.
Yeah, in this particular case, what I have right now, it wouldn't need to box because the type inference can figure out that they're strings. I unfortunately don't have an example for this. I can define add to be generic in this style. Now it would not need to box. Now it would work like the generics in C#. But if we're running it with the type infer, with whatever syntax that I'm forgetting, it would need to box. So there's a lot of awkward combinations that can happen sometimes.
And if I were to define a type foo and then define an operator plus for it, that would work as well.
I think so, yes.
Because that's, yeah, okay.
Mm-hmm. Okay. Okay, and then I want to move on to a concept called railway-oriented programming, which is again a concept or a concept which takes advantage of function composition and partial application. And if there's any of you that have taken a look at Rust, at the Rust language, this is actually the only way how you can handle errors in Rust. But it's the main usage of railway-oriented programming is error handling through function composition. And you just, using it, you have a very clean control flow. And you can even treat your errors as first-class citizens. So you can pass errors around like values, you can pass them to functions, you can return them, you can handle them at any point in the application that you want. But it doesn't have to be errors, it can be anything really. But it's usually used with error handling. So once again, if we take a look at the C# example, we would need to validate our string input. If it's null or white space, are we going to return a string or should we throw an exception? And then we're going to try catch around our convert to JSON and update a user in database and then convert that to JSON. What happens when we have a database exception? Should we return a string here or should we rethrow the exception further up the stack? So there's a lot of design decisions that goes into play here. But what if we go back to our magic boxes? What happens that while we're casting our magic, an error happens? Well, we can model it like a railroad. So we have our function input and our happy path output. Or if some kind of error happens, we can then reroute our track into this bottom sad path. And now we can just use function composition to plug these rails together, just like with any other function composition. But what happens right here, where does this go? So this is where we can actually wrap our function in another, what's usually called a bind function, where it takes a single input, now it takes an object of two inputs, and essentially makes our functions look like this. So all of our functions would now have two inputs and two outputs. And anytime we land an error case, if a function receives an error, it would just continue passing the error along without trying its own logic. So what this looks like with actual functions, for example, we have a validate function, an update function, and a send function. They would all have this switch within them, and you can compose them together. So what does this look like in code? So once again, we have a very simple user type. And our railway track is what's here a result. And here we see actual generics like the .NET C# generics. And it's a discriminant union of either success of whatever a success object is or failure of whatever a failure object is. Usually this can be the actual exception object, or it can be a string or whatever, and success is whatever type that we're actually dealing with. So if we have a validate function, it takes in an ID and a name. We're just going to validate that the name's not empty. If it is, then we're going to return failure. Otherwise, we're going to return success of ID and name. We have an update function, which updates our name in the database. And essentially, that's the ID has to be 0 or greater to be successful. Otherwise, it'll return none, in which case, if it's none, then failure, otherwise success. In this case, our success is of type user. Up here, our success is this tuple of ID and name. But in both cases, the failure is a string. And the same thing with a send function. We're going to try to send a response. This is an F# try catch, and we're just ignoring our exception. Once again, we're returning some JSON, or in the failure case, we just have a failure string again. So what's important here is none of these functions know how to accept a failure case. All of them are just accepting their regular inputs. So the send function is only accepting our user, but it's returning a result of string. Our update is accepting a tuple of int and string, but is returning a result. Same thing with a validate. It's accepting a tuple of something, that's the ID, and our name, string, and returning a result. So what we need to do is we need to bind these functions. And this is essentially wrapping our functions in another function, which allows the function to take a 2-track input. So if we receive a failure, it just passes the failure through. However, if we receive a success, we're going to deconstruct the return type and apply it to the next function. And what this looks like, we can now create a workflow. Validate, we can compose that with our update function that we've wrapped in our bind. And we can compose that with our send function, which we've wrapped with our bind. And now a little demo. So workflow result 1, our name is empty, so that should be an error. And second example, the ID is less than 0. That's an error. And these two are good. These two are happy path cases. And our output, we have workflow result 1, 2, 3, 4. Failed with message, input must not be empty. Failed with message, and then 2 times succeeded with message. And this is a very powerful construct that really allows for very simple data flow. You can very easily see, looking at this workflow, you can really see how all the different steps that the data flows through. You can really follow along. You can follow along the individual functions. You know exactly which function comes next. And you can, at the same time, know exactly how the errors get handled. And at the end, you can handle the error however you want. You don't need to have your logger inside each function. You can just have a single logger at the end of the workflow.
I assume most of this is in the standard library.
Yes. So this result type is also in the standard library. This combination of composing with a bind function, I forget the imports for it, but usually there'll be a second operator which looks like that, which will automatically add the which will automatically wrap your function. But I forget the imports right now. There are, of course, other third-party libraries that other people have implemented that try to take this concept further. Other fun things you can do with rail-oriented programming is instead of having just a single track, you can break out into parallel tracks and then combine them all again. You can have dead end tracks. So for example, if you're just printing something to the console and you don't care what happens, you can have a track that branches off while the main logic continues on. And it's a lot of fun to use.
So basically an error handling strategy.
Yes. Any other questions? Okay. So we're getting slowly towards the end. There are two more concepts I want to talk about. I think I'm going to talk about the other one first, which is just a really cool F# feature called type providers. So this is all of my code I have for a type provider. I may have one project reference, a NuGet package reference, I mean, which is the type provider library. In this case, it's called F# data. And I only have this one file. I really want to prove to you that I have nothing else here. So what happens is we define a JSON provider, and we're going to let it read in a sample JSON file from Reddit. For those of you that didn't know, if you go to any subreddit and then go to /.json, you get a JSON representation of that subreddit. But what this allows us to do is allows us to get statically typed access to whatever resource we're providing types for. What that means in this case is our JSON. So we have our posts, which we load our JSON response. So in this case, we can load the F# subreddit, we can load the programming subreddit, anything we want. And before I go into that, I can show you that the posts of first of all, I need to grab, it's a list, so I need to grab the first one. And now here we see the subreddit, we see this is not what I'm looking for. Of course it's broken right now in the middle of the demo. What else would it do? What did I just do? Nothing changed here. Oh no. I'm so sorry, guys.
No worries, Murphy is always there. No matter if it's C# or F#, Murphy is always there.
Yeah, I'm so sorry. I won't be able to run this, but so essentially what happens is that post is a list of the JSON response. And if so this is what the JSON response looks like. It has children, and each of these children has a post. So the title would be welcome to F#, the self text. We have author flair, we have name, we have, where's the actual author that I'm looking for? So this is all a JSON file.
So this is based on an example JSON, or
Exactly.
could this, is there a type provider for the current draft of JSON schema? Because I heard there was one, but for some reason it's no longer actively developed.
Okay, I personally have not used the JSON schema type provider. I'm pretty sure, like you said, there should be one. It would surprise me if there isn't one.
Yeah, because you can see in this example JSON, there are some empty arrays.
Yeah.
You don't know what's in there. There are some empty objects even. You have no idea what's in there.
Exactly. But for those that don't know what these type providers are, it actually automatically figures out during compile time that I have an author field. And that the author is an option type because this author, for some reason, is a int64 or string. Now, of course, the compiler is there. That's an int64 or string. So I'm just going to grab the string out of that.
How can it tell that it's an int64 or string if there's only a single example
sure that
JSON?
Somewhere in here, because this is 26 different posts. One of those.
There are multiple examples.
Exactly.
That hopefully are representative of all the ways this JSON data can be filled.
Exactly.
Okay.
So it knows it can automatically generate the type for the author. It can automatically generate the type for any of these fields here, and then we can just run any statistics we want in it. For example, we want to get a list of every author that has more than one post on the front page, and maybe no, I really don't. Maybe it'll magically work. There we go. Oh, now of course it ran. So these are it pulled directly from that JSON file, from the remote JSON response. So these would be on the front page. Out of these 25 responses, these 4 people have more than one post on the front page right now on the F# subreddit. These things are really cool. There's also a SQL type provider. Where's my Visual Studio?
And I guess for XSD as well.
Yeah, XSD. There's even very specific ones like the Twitter API, XML type provider, HTML type provider. You think of it, there's probably a type provider. So the idea here with this specific type provider is I write my migration script, and then I write an insert statement. So insert into users, username and email. If I make a typo, it's going to take a short moment, but it immediately knows this is a string. This is a string, and it tells me I have a compiler error.
What kind of syntax is that with the angle brackets after SQL?
This is how type providers are usually defined.
Okay, so it's type provider syntax.
Yeah. Mm-hmm.
Okay.
So we're defining a type alias with a type provider using this as the type provider, for lack of better term, constructor. Same thing with a select statement. We can select star from users. So for example, we can insert user using these 2 commands or parameters here, or we can select users and we have select star, or it should even give us autocomplete. Sometimes it breaks, sometimes it doesn't. But we did have the compiler tell us something was wrong the entire time. Now we can give it a type alias. Now this SQL syntax is correct, but now down here it tells us that the email field does not exist. So we can autocomplete that to email address.
Yeah, that's really cool. If you were to misspell select, I guess it would notice as well.
Exactly. There it has like select unexpected end of input. Or if I add a where clause, there is an ID field, I think. So now, once again, it tells us that there's a problem here because we're missing our parameter.
So it's an entire inline SQL parser plus the interop with the F#.
Exactly. And this is all done at compile time. This is not Visual Studio specific. You can do it with any editor. You can do it with .NET Framework, .NET Core even. This specific type provider uses migration scripts to generate its types. So it takes it from here. There are other SQL type providers that actually, where you give it a connection string to an actual database, and it'll pull the schema out of that. So that if for whatever reason your database server has a problem, it goes down, your code will stop compiling.
If it compiles, it works.
Exactly. Exactly.
How difficult is it to write a custom type provider?
I've never done that.
Okay.
The basic idea is not that difficult. You just need to know a little bit about metaprogramming. So the F# version of the C# expression object, as well as a little bit of reflection. But just last week, there was an F# conference, and one of the talks was about writing your own type provider.
Because in my head, I was comparing this to writing Roslyn analyzers with code fixes, which I find far from trivial. So writing type providers is easier than that?
I can't. I don't know. I've never done it. I've never wrote a Roslyn analyzer either. But these things, coolest feature in F#. Yeah, and I wanted to quickly go over my last.
Can I ask a question about this?
Yes, of course.
Yeah, so you say that you need actually connection to a database to make it compilable. How you deal with it if you want to build on the build machine?
So
where
again,
you probably don't have anything.
Yeah, so that depends on the specific type provider library. The one that I'm thinking about, you can give it a connection string to a database or you can give it a schema file, and then you can connect the, then you can check in the schema file alongside your source code files.
Or even fetch it in your build pipeline.
Or fetch it in your build pipeline. Yeah, so that's another thing. It's like if you are using it with a connection string, then you can't work offline, right? You can't work on an airplane, for example.
Yeah, probably
unless,
fetching it in the build pipeline is preferable because it won't go out of date.
exactly.
But on the other hand, wouldn't that mean that you first need to update your database and then compile your code? So it's
Exactly.
kind of...
That's so the other one is a database first approach, which is why I personally like this one called Resume. This one's a code first because you don't need a live database, you just need a migration script.
Ah, okay.
And then if I rename this second migration script to the proper format that it's expecting, I should now get a compiler error because I've renamed my table. So a migration script, it'll first, generate the types here, and then it will generate the types here. And now I should get an error in a moment.
Is there an error in your SQL script? I think
No, that's just because Visual Studio is expecting MS SQL syntax.
Okay.
Yeah, SQLite syntax. There should have been an error now. Oh, come on, really? This should error out.
Maybe build it.
Yeah, there we go. Build failed. And it's not showing me what the error is. My computer's all kinds of...
Console never lies.
Where's my console? Yes, exactly. So no such object users, because I've now named it. What did I name it? People. And now it should
that's
compile
awesome.
again. Yeah, build succeeded. Yeah. So huge fan of this feature.
That is a very good feature that I would expect it in C# much sooner, to be honest. I don't know why it's not there anyway.
I don't know of any other language that has this feature.
That
I would
is
even
amazing.
expect this. Sorry. I would even expect this to be in C# first and then in F# because dealing with databases is not really functional. So why put it in a functional language and not the historically imperative one?
Well, the thing is, like my other example is a JSON file. Or there's, for example, anybody that knows Swagger, the Swagger for writing specifications for a REST API.
Yep.
There's a type provider for that. So you have a Swagger API definition, and then you just write a REST client against using a type provider. So it's always compile time in sync.
But isn't the REST kind of against a functional idea? I mean, you can do it, of course, but with the resources that you need to have specific resources for each one of the calls, and how do you how do you map a resource to a are you calling the database directly again? I mean, sort of, kind of, right now, I couldn't think having immutables, for example, with that. How do you have an immutable type and fill it with data and all this thing?
Yeah, so this is one of those things where like if you really take the functional paradigm 100% and you want every function to be pure, then your program's not going to do anything, right?
Yeah.
Exactly. So it's one of those things. It's like you want like kind of like 80% of your functions, like in a best case scenario, you want something like 80% of your functions to be pure and then the rest to be impure. Because it's like, once again, if all of your functions are pure, then you start your program and then you just your computer just kind of heats up a little bit, which is actually a side effect.
How is the separation between pure and impure functions in F#? although I've never programmed in it, I understand that in Haskell there is a quite strict separation with a special keyword.
Exactly.
And in F#, does interoperability with the rest of .NET force F# to let you to allow mixing this in your functional code? So it's your own discipline.
Exactly. So let me see if I can have a quick example. So let's just say this database.
The print is an example.
Where's my print? Yeah, exactly. So the print, the type signature is a text write formatter and a generic. If this was Haskell, there would be an additional return type, the type IO type. So Haskell actually has, if it's an impure function, if it's a side effectful function, it's part of the type system. And there's a compiler check that where you're not allowed to call an impure function from a pure function. F# doesn't have this restriction because F# takes a more pragmatic approach. But also because it is on .NET, it does need to interface with C#, with the .NET Standard Library, with the BCL and all that. It has classes, interfaces, abstract classes, all that. I think we're out of time, so I don't know if I have enough time to talk about monads. I can go through it very quickly if you're interested.
Yes, please.
Okay. So this is always a fun one. Anytime you read anything about functional programming, at some point you're going to hear the word monad, and somebody will tell you that a monad is just a monoid in the category of endofunctors. What the hell does that mean? Absolutely nothing. To put it simply, it's essentially a wrapper around a type, a data structure, that you can perform additional operations on. So, or a very, very simplified version. Imagine if the semicolon at the end of your statement did something extra. So for example, if every time you wrote a line in C# and you have a semicolon, it printed to the console what you just did. That would be a monad. Every time you have an async function, you write the semicolon, you wait for this async function to finish. Like async await. So a little more detail about a monad. It's essentially a type that takes a constructor that wraps a value. This is called the monadic value M. It also has a bind function, which takes a function, and it applies this monadic value M to that function, and it returns the return of that function, once again wrapped as a monad. And then of course there's a return function which unwraps the monadic value, giving you the internal value. I don't know how many of you know JavaScript, but if you do and you've used the JavaScript promise, you've used a monad. Because we're wrapping our value within a promise where we can chain, we're using then, which is still a promise value, but we can call another function inside this then, and we can continue chaining. And interestingly enough, this is also an example of railway-oriented programming, where we can catch, for example, if this is an error, we're just going to skip over this then and go straight to the catch. So double whammy right there. What does a monad look like in F#? F# has a syntax sugar called computation expression, and these are actually not monads, but they can be used to represent a monad. So if we're taking our async example, we can define our async computation expression. So this exists in the standard library. And here we see a let bang. So let with an exclamation point. If we're getting from the database by ID async, and our return is a string, and because we're calling it with let bang, we're going to use the bind function of the async builder, which in this case is waiting for it asynchronously. Same thing with the replies, get replies by username, and we're going to wait for it. Within this computation expression, we can also just have completely normal values. And then here we actually see our return statement, which unwraps our value from the monad. Now for a quick code demo. So we have a very simple version. So our printer again. What happens if at the end of each statement we want to print to the console? We would have to declare a value, print, declare a value, print, declare a value, print. That's boring, right? So we can define a print builder with a member. So this is actually F# syntax of how to define a class. This compiles to the exact same thing as the C# class right here. We define our bind member, which has our value and the function we want to apply to it. It's going to print our value and then apply the value to the function. And also a return value, which just unwraps the value. So now we have our printer. We have let bang. And we just assign 10 to our decade, age 28, some other random thing just to prove that we can. And then we're going to print the result of decade plus age. And if we evaluate that, printed value in computation expression is 10, 28, 38. So nowhere.
And you can use the computation expression because type inference told F# that printer has a bind member and a return member.
Exactly. So interesting enough, if I were to actually comment this out, it should yell at me because this control construct may only be used if the computation expression builder defines a bind method. So we're inside this magical syntax sugar with a let bang expression. That's a very simple use case. For a more useful use case, once again, web request. Imagine we're getting a query parameter, but we want to make sure that it actually exists. So once again, our option type, if our parameter actually exists, we return some, otherwise none. We want to validate it. So for this query parameter, we want to make sure that user ID exists and that it has a value. So to do that in the normal case, we would have a pattern match on the query parameter from the URL. If it's none, then return none. If it's some, then we get the internal value, then we have to validate it, which itself is an option, which we have to pattern match on. And we just get into a nested statement here, nested expression here, which is ugly, difficult to read. But it works. It works just fine. Query parameter value is 123.
And it's better than forgetting to handle error cases.
Exactly. However, we can define a maybe builder where our bind does this pattern match, and then we can return the some value. So now the same thing, we have our maybe. We're going to bind using this special syntax, get query parameter, validate, and then we're going to get the actual value out of it, and we're going to return it. And now if I run all of this, this is a lot easier to read. And it works just as well. So now we have, in this case, query parameter value is 123. In this case, malformed, malformed, malformed. And I would say that this is a lot easier to read. And that's a monad. That's a lot simpler than if you were to read what the type theory people say about it.
So the monad is in F# a special case because there's this special syntax. So this is baked into the language explicitly.
Exactly.
In contrast to Haskell, where this is a type class and you can have type classes, whatever you want, and in F# you can't. But one of the most important type classes is baked in. Yeah,
exactly. But like says, even the JavaScript promise, which almost all JavaScript, unless like you're just day one learning JavaScript, you gotta know how to use a promise, and that's also just a monad. So the general concept of monad is a lot simpler than the type theory says it is.
Are there useful type classes that are built into F#? Because as I understand it, you can't just define them.
Yeah. So one of the things that F# as a functional language doesn't have that other functional languages does have. That's called type classes, like you said, or higher kind of types. It's something that's slowly being worked on as a proposal in the C# called shapes. A proposal. They're strange. I unfortunately I don't really know how to explain it well. And other than monads, I don't really know if there's. I don't know off the top of my head if there's other ones that are built into the language right now. But it is slowly coming. Before there's more questions, I just want to say that's the end of my presentation. Additional resources if you want to learn. Of course, the official site, F# for Fun and Profit. That's a very good site. That's what I mainly used.
It's amazing.
You can try F# online if you have Silverlight still. Once again, the link to my GitHub to this exact presentation. And this is the link to the presentation about what the functional paradigm is about. So here he talks about how to make a tiramisu cake, first using imperative approach and then using the functional approach. And why and how the two differ from each other, and why, in his opinion and in my opinion, the functional approach is better. So with that, I want to say thank you, everyone. And any other questions or any other feedback?
Yeah, I have some. First of all, yeah, thank you. It was really interesting. And if you would like to switch back to your demos, I have a question regarding this railway demo.
Yes.
Railway-oriented demo. Yeah. So here, yeah, you validate, then you update and send something. But what should you do? How you express it if you want to do something in between update and send?
So very simply,
So,
we can
yeah.
You can validate and find update, and then let, so we can just break our workflow in two. So in this case, we can have our intermediary value. Come on, intermediary. That looks, this will take this, and that returns our result. And now we can do whatever we want in between.
Okay, so you need to have intermediate variable to
exactly
kind of store this result. Okay.
You
yeah,
can do
I just
that with binding
making
as
some
well.
kind of comparison with Rust, which have also supports this railway oriented.
Exactly. So the Rust doesn't actually have exceptions, and the way they handle their errors is with this result type. It looks very similar. I've never actually used Rust. I've only read a lot about it. But I'm very interested in trying it because of things like this. This is how Rust does all of its error handling.
Yeah. Okay. Yeah. Thank you. I have yet another question. You didn't mention it, but yeah, I've seen in one of your examples this async computation expression, which actually great, yes. But how about interoperability between F# is still .NET, and you have a lot of libraries which are using async await, so tasks based programming, and here, as I can see, you need to start this routine, or I don't know how you call it, and it actually will create a treat that will execute this code and so on and so forth. So actually, to make an async await call in some .NET library, I need to create another thread here.
So this, oh, come on. So this is just to, this could be run synchronously, or you can have it as start. If you want to pass it to a C# library, you can start as task. So now this is actually our system .threading.task object. So there's a lot in the, this is now coming from the F# standard library. This is a system task. Come on, where's my import statement? Okay.
It's clear.
Yeah. So this is coming from the F# standard library, where we can convert from the C# task to the F# async. And at the same time, this entire thing is an F# async, but we can start it as a C# task. So we can freely convert between the two. And then if we have,
we lost you, Kai. Anybody else is online?
Yeah, I thought it was my connection.
Still here, yeah.
Ah, so it's just Kai's connection.
It looks like.
Let me try to contact him. Thankfully, it was near the end, but we should say, let me try to send him a message. Very interesting things, but a lot of things, right? I mean, at least talking from my behalf, I need time to process them.
I can only recommend the F# for fun and profit page. You can read for a week if you want.
Really,
So
but
different examples, different ways of doing things, from the basics to the also railway-oriented programming. It's an amazing page, amazing site.
Oh, Kai is just telling me that internet is down and he will be back in a minute. So yeah, that was a question that I had already. Profit was a nice word. So it is nice for fun. I can understand that, and it's very cool that we are recording this because we can go back and start playing around. At least on my side, that would be very useful. But what kind of industries do you think that will be benefit from F#? Which kind of programs, applications? How can you actually make profit that way and work as a developer with F#?
I think traditionally banks, especially in London, use a lot of F# for complex data modeling. But also there's a company called Jet.com, and they created a new e-commerce solution which supposed to challenge Amazon, which is a big ask. But they were actually so successful. They've been bought by Walmart, and so they have a really sophisticated kind of e-commerce solution where the price, depending on where the product is located in which warehouse, will be recalculated like every second on GPUs and so on. So that's one part. But I think with Fable, basically the online language to create web applications to transpile to HTML, CSS, and JavaScript, you can create just normal web applications with it in a type safety way. And there's also now, I think, the drive from the community to push forward F# for data science. That's another part. And yeah, especially for event sourcing, it's well known. And I think complex domain applications benefit from these kind of algebraic data types because it's compile safe. And there is a great book by Scott Leshan, who also is the writer of F# for fun and profit. And the book is called Domain Modeling Made Functional. And he's just awesome. I just went to a workshop which was done by him in Amsterdam, and that was at the Domain-Driven Design Conference. And I mean, if you dig into this, it's just brilliant. So you can probably provide really in a fast way very complex domain solutions, like for, I don't know, energy, finance, any kind of stuff. And but you could also write some simple web applications very quickly with it, and do data analysis with type providers and so on.
Yes,
Super.
I'm back. Sorry for
hey.
that.
Welcome back.
So I've pulled up the Twitter page of Scott Laughlin. But yeah, like Volker said, very, very good man. And you right now, you can also see here on Twitter, Don Syme. This is the actual creator of the F# language. Thomas Petlicek, he does a lot in the community. He's written some great libraries. Sergey Tihan, I don't know. He writes a interesting blog, which I like to check in. F# Weekly. So every week there'll be a bunch of links posted to various blogs by people from the community, language proposals, GitHub projects. It's very interesting.
It's a very active community, right?
It is a very active community. It's more active than Microsoft themselves, which is something.
Yeah.
Sad, really.
Yeah.
No, go ahead. Sorry.
No, I was just about to say that, yeah, I think there is a learning curve here, especially to get used to the syntax and try to see and easily understand what you have in front of you, because right now everything for me it's like an effort, right? But it would be super beneficial, because not only for fun or for profit, but even if you continue to be a C# developer, in order to understand why they're bringing some things in C# like records, for example, C# 9 or pattern matching on all of these things, it would be super to be able to write here and there, or anyway understand F# easier. So that was really amazing for me. That was really helpful.
Yeah. So it's interesting. It's I don't know how long any of you have been programmed, but if anybody remembers C# before async await, or if you remember C# before lambda expressions,
Yeah.
you were just kind of writing C# and you're like, okay, yeah, whatever. And then lambda expressions came, and then you were just suddenly thinking, how did I ever write code without these?
Yeah.
It's the same thing with F#. Sure, C# is slowly getting these features, but F# has had them for years and years, and it's in the community, it's in third-party libraries, it's in the standard library. And if going back to C#, it feels like that. Just kind of like, oh God, I want my pattern match. I want my discriminated union.
But I mean, why do you think that the C# has this broad audience where F# doesn't?
One of the big reasons is marketing. So C# started as a competitor to Java. And it worked as a competitor because back then Microsoft was doing a lot of anti-competitive behavior and like pre-installing C# with the .NET framework on every Windows machine.
Yeah.
And then it just kind of picked up from there. And then F# in the beginning was a research project. It was marketed towards data science and not general usage. And then it was just always left on the sideline. They never really pushed for F# adoption in the community. They never really talked about it at their MS Build conference, for example. Even now, every year, F# has gotten a bigger and bigger community. And even at the MS Build conference, what was it, last month, 2 months ago? Not a single mention of F# was made. No matter how much influence F# has had on C#, they did not mention it once. Yeah,
you're right about that. I mean, most probably the competition with Java plays a significant role, because it's very easy to get Java developers to write C#, right? The syntax
exactly.
Very well.
That being said, I'm hopeful that it's all slowly turning around because of JavaScript, actually. Since React.js came out, the front-end framework, there's been a lot of talk in the JavaScript community about functional code, about pure functions, about higher order functions. they're suddenly interested in the functional paradigm, and as I've mentioned, they're also talking about the pipeline operator as a proposal. They always mention F# as an example, so it's starting to look up there. There's a very interesting project in F# called Fable, which transpiles F# to JavaScript. And I
Compiles
think,
F# to JavaScript.
yes.
Oh,
So you can
that's
write
good.
F# code to run on Node.js. You can write F# code to run in a web browser because it transpiles to JavaScript. And then you even have your isomorphic F# in the back end, F# in the front end thing. I think Sven is raising his hand.
Yeah. I was going to make one remark and then I have two questions.
Okay.
One regarding Fable and another one. The first remark to who was talking the whole time? Sorry.
George?
Ivan?
Kai or George, or I don't know who you're.
Oh, you.
Me as George?
No. I've never programmed in a functional language more than fiddling around, but even just reading F# for fun and profit, reading about F#, especially also type providers, and also reading about Haskell, which is a, let's say, more pure functional language than F#, has changed my way of thinking when programming in C# for a living. So even going through this school of thought without ever programming in one of those languages also has an impact on your development style, and I think it's a positive impact because you start thinking about problems from a different angle. You start thinking about higher levels of abstraction, which are even possible to do in C# with a bit of boilerplate and implicit conversions and a bit of sing and dance to make the compiler happy, but can pay off. So just going through that school of thought is well worth your while.
I think also, it's maybe the companies who are using F# should be a bit more upfront about it and just demonstrate how they optimize their system using F#. Like I said, for example, Jet.com, they in the beginning, they made a comparison between C# and F#, how to implement a certain feature. And they found out like they can save lines of code by a factor 10 or something like this. Mm-hmm. So yeah. they decided to implement everything in F#.
Yeah, there's also an interesting talk about by Colin Bull about a project that he worked on. It was a large client. They were doing some a software which calculated what was it? It made a lot of measurements from live sensor data and had to display them in a dashboard. The initial project was 3 years, 5 developers, C#. After all that time, they weren't able to meet all requirements to 100% accuracy, and there were a lot of bugs, a lot of null checks, a lot of small little, a lot of refactorings that needed to be done, until they somehow managed to convince the client to restart the project new and write it in F#. And they went down to 3 developers and 1 year, and they were able to complete every single requirement to 100% accuracy, with about a third of the amount of code, almost no null checks, and just practically no runtime bugs.
That's probably the most famous graph in F#, right?
Yeah.
That graph. Yeah, my 2 questions, one regarding Fable. How seamless is it to write, for example, your validators, your, say, your domain primitive validators in F# and then use them in the front end, say in an Angular project or whatever, and in your backend as well? How painful or how seamless is it?
So usually in the front, it's going to be React because that's just what the community has decided would be the most common use case. But it's rather painless because you're already focusing on writing pure functions. So something you can do is you have all of your shared logic in a separate project file. And then your backend, your backend server would reference that project, and your frontend would also reference that same project. And since they're pure functions, the one end is compiled to IL code, and the other end is transpiled to JavaScript code, but it's the exact same source code, and it's rather painless. It's very painless.
Okay, that's good to hear. And building on top of that, how is the interoperability between C# and F# within the same solution? Because now imagine I have my let's say I have just the validators, pure functions in F#. I like to call them from my C# code, because to me it seems like F# is great for modeling not only domain data and using the type system to already have half of the domain logic encoded in the type system and compile time safe, so provably correct, and then only fill in the gaps with actual code. And it would occur to me that I could have an F# project where my entire domain resides, and then do the stuff that has side effects, meaning returning HTTP responses or updating the database. Do that in F# because all the libraries throw exceptions, and those are more at home in an imperative language.
Yeah. So
how painful is that?
The interop using C# from F# is usually very easy. Like
I mean the other way around.
Exactly.
Like imagine the F# would be its own universe. That's just the whole domain. And everything else, that's the inner part of the onion, basically. And
exactly. So once again, if you have your pure functions, it's no problem at all, because a module in F# compiles to a static class. But most of the time, any third-party library, they're going to have a specific couple of files dedicated to wrapping the F# code in something that makes it easier to use from C#. So for example, we have fscheck, which is a property-based testing library. And they write all of their examples and how to use it from F# and then how to use it from C#. And this is accomplished by having a wrapper. So you have all your F# syntax, and then you have one more file that's dedicated to wrapping all of the F# types in something that makes it easier to use from C#. So that's something that you will have to worry about as an F# library developer.
So would you say it's a good idea to have your entire domain logic in F# and then do the in and output in C#?
Sure, absolutely. Especially if you're if the edges of your domain are thin. There's this fantastic website called sharplab.io where I can actually show you. So if I have a module foo, this compiles and then decompiled to C#, we have a static class foo, static int add int a int b return a plus b. So same thing with a type. I don't write many classes in F#, as you can see.
Because I can imagine that having, I mean, there are a couple of concepts in F# with the algebraic data types and
exactly
unions and everything that you don't have in C#. And as soon as I have those in my domain and I need to access them in C# to update the database from them,
exactly,
that could be painful.
So that's exactly where it becomes difficult, and that's where you start going to need your wrapper types. So right here, these two lines, so this is an F# class and an F# module. The C# class, it's very easy. Class bar, int add, class foo, int add. However, as soon as I throw in a discriminated union, my output is massive. So these are some of the areas where you would need to write some wrapper logic so you wouldn't expose the discriminated union to C#.
Yeah, but they're part of the domain, and
so
I need
that's
to use them.
so yeah, that's where you'll have to have some kind of function that accepts a class and converts it to a discriminating union, or the other way around. So those are some of the places that will take some extra work.
Okay, would that be worth it in your opinion?
If it's only one or two types, yeah.
No, I mean an entire domain model,
Yeah,
which probably will be heavily based on all the F# type features.
yeah. That does become more difficult. Yeah. So probably not.
Okay, so rather go with F# and the awesome type providers.
Yeah.
Okay, thanks. Great talk, by the way.
Thank you. Anyone else?
Have you ever
Yeah.
sorry.
Can I? Oh, okay, Volker.
No, go ahead.
Okay, yeah. So I just think that compiler actually makes a lot of cool stuff here, and yeah, it actually really helps you to be productive, and the salt types provider magic and so on and so forth. But you still have to, you know, what you said at the beginning, that you need to keep the order of your files in the right way. So why compiler just couldn't check that you don't have any kind of circular dependencies and leave you with your files with the order of your files as all other programming languages allows you to do?
So this is actually one of those things that in the beginning everybody always thinks that it's a bug or something. It's actually designed this way. They wanted it this way, and
I believe it's come from ML
exactly,
or
yeah.
CAML wherever it was actually suggested.
Mm-hmm.
But yeah, it's kind of old school stuff which
Exactly.
might be avoided.
So the short answer is it once again forces you to think about your data flow. It really makes you it's like if you're reading code, you can read it top to bottom. That's ISO. If you're coming into an unfamiliar code base, then you can start at the top and read to the bottom. You're not constantly jumping between files. And at the same time, if you're writing code, it forces you to think about your data flow. It forces you to say, okay, I want to do this with my data, and then I want to do this with my data. If I want to have some kind of combination of the two, then I'm forced to think about how I want the combination to work together.
I think also when you have a look at the somewhere on this blog of F# for Fun and Profit, you find a comparison of C# library, code analysis, basically complexity and circular dependency, and F#. And it's just amazing because just by defining the order, you get less problems like this. But what Scott Blushing found out is one of the core, I forgot which one it was, but one of the core libraries of C# has such a huge complex code dependencies that it's, and especially with circular dependencies, which are really hard to solve them. And you can avoid this much better in F#, I think.
So I do remember this article now. The basic idea is essentially exactly as Volker said. It's like how do you think about your circular dependencies? It's like at what point do I instantiate which class, which references another class, and has that class already been instantiated or not? And now I need to check for the null case, or at the same time I also need to check for the not null case to see how deep it actually goes. And at the same time, it also makes it easier to call code from code that you're not supposed to be calling, because your architecture says to use your data structures in a specific order, and then it just becomes a lot of cognitive overload. So this is another reason. So if you're just forced to go from top to bottom, then this entire problem just goes away. Yes, you will have another problem of having to figure out how to represent your types in this with this constraint in mind. But it's a lot easier than it sounds. So yeah, this is cyclic dependencies are evil. This.
Yeah, absolutely agree. I just was thinking that probably compiler should solve it, not me. Yeah.
It's all part of the pit of success.
Exactly. But like I said, you can use special keywords to get around it.
Okay. Yeah. Great.
I'm actually working on a library which requires circular dependencies. And if where is it? Nope, not here. So if I actually just define the entire module as recursive, then suddenly everything is circular. I can reference it in any direction. But once again, this is one of those things. It's like you need the extra keyword to turn off the default, so that if you're doing it in a team, for example, and you open a pull request, then you can decide as a team, is this a good decision? Why are we doing this? And then you can say, okay, yes, I think that's a good reason, and then you can continue. Or somebody else could say, oh, but we could solve it in this other way. Okay.
Have you actually had a look at F# Plus, the library?
I have not. I've looked. I've seen it mentioned every now and then, but I've never actually taken a proper look at what it does.
Yeah, there was a talk I think on the F# Meetup, the global one, and by the author, and it was brilliant. Basically, kind of applies a lot of Haskell concepts in F#, like lenses, for example, for very complex data types and so on and so forth. But yeah, I haven't tried it myself yet.
Okay, just for those that don't know, a lens, if we go back to records, so a lens, it's now without syntax idling, but if I want to copy a record and update a single value, but what if this value is a nested record, is a nested record, is a nested record, is a nested record, and this copy syntax would become very big and ugly. Lenses are a concept with which you can drill directly into the property that you want and update just that one piece, still in the functional way, by keeping everything immutable. Just quick side note.
A couple of lens libraries are also upcoming for C#.
Of course they are.
With a lot more boilerplate, of course.
Okay. I think with that, I'll give back to George.
Yeah, that was really, truly amazing, Kai. That was the start, let's say, that I wanted and I was looking for. So I really enjoyed it. Thank you very much. It would be very cool to have another meetup sometime in the future. I don't know, November with .NET 5 or something, and all these C#9 features. We could see all these C#9 features, but in F#, how they were there, and so we can have a comparison of what we are looking. In any case, it was amazing. It was really nice that we are recording it, because now we can actually see it. To be honest, there are, at least on my side, a lot of things to process, and I will definitely need to see the recording again. But it was a great start for me, I think. Thank you very much. If there is nothing else by Venian, then we can stop the meetup. Yeah?
Right, thank you, George, for hosting.
No problem at all. Anytime, I'm sure we will talk again and we can repeat that at some point. Then, ciao guys. Have a nice afternoon and a long weekend.
Bye.
Bye.
Thank you. Bye.
Bye. Thanks a lot.